All right, this is section 1.1 of our geometry textbook, and we are going to get started today by introducing a few new concepts. And we are going to start with the most basic geometric definitions. So we're going to start by first defining what a point is. And that bullet that I just made in front of the word point is actually a point itself. It has no dimension. And it is represented by a dot. All right, so if I change my color here now to blue, if I just put a point here, most of the times you'll see a point labeled with like letter A, and we would call that point A. And you always use capital letters, and I've always seen points lettered with or labeled as a letter. I never see like point 1 or point 2. And then if you connect two points by a line, that is what is called a line. There's different types of lines. There's line segments, all sorts of stuff. But a line has one dimension, the direction it is going, and it is represented by a line with arrowheads on both sides. And now the cool thing about a line is that it extends indefinitely. So it just goes on forever, infinitely, in both directions that the arrowheads are pointing. And so if I draw a line here, we need to put an arrowhead on both sides. We could have a couple of points on this line, like A and B, and now we would call this line line AB. And it does not matter if which letter you put first, so we can also call it line BA. And now I know you guys don't like writing out the word line all the time, so we have the shorthand, which is going to be an arrow on top, or a line on top, arrowhead on both sides with the letters A and B below them. Or you could do the line on top with the letters B and A below that. Now you'll notice that as you're working through some problems, there's some lines that just have labels on them. So if we have an L here, we can just simply call this line L. And you'll see that if there's lots and lots of lines on a figure. And now if we connect a bunch of lines together, we can form what is called a plane. And a plane has two dimensions. And imagine a plane like a wall or a tabletop, the ceiling, the floor. It's normally represented by a rectangular shape and it's flat. So we could draw a picture of a line, and we normally represent that by like a rectangular parallelogram shape. So we'll go ahead and draw that up right now. And so here is our representation of a plane. We could put several points in this plane, so we could have like a point A, a point B, point C. Notice that if we draw any lines between those 3 points, like this, or like this, or like this, those lines are all in the plane. So we can call this now plane ABC. And sometimes you'll see planes just have a letter floating out here, and if you see no point with that letter, that is simply going to be called plane M. That M is a label, not a point. All right, a couple more definitions that might be useful for us is the terms collinear points and coplanar points. And so collinear points are going to be points that lie on the same line. So points that lie on the same line. So if we go ahead and draw a line over here and put the points A and B right here, we would say that A and B are collinear. But if we have a point C floating over here, notice that A, B, and C are not collinear. They're not on the same line. And coplanar points are going to follow a very similar structure. So coplanar points are just points that lie on the same plane. And so now if we were to draw a plane over here, and we put the points D and E on this plane, notice that D and E are coplanar with one another, but D and E are not coplanar with any of these 3 points up here. They're all on separate planes. All right, so now that we have the definition of a point, the definition of a line, definition of a plane, collinear and coplanar points, we can now do our first example for section 1.1. In our first example, we are going to give some other names for some objects within a plane. So we're going to first draw our plane here. And this plane is going to take up a little bit of room. So we'll draw it right here. There we go. And our plane is going to have this label R down there. Remember now, R is not going to be a point on this plane. There's going to be a line on this plane that's going to go across it diagonally. And it's going to have the points on it S, P, and T. And then extending upwards, we have a ray, which we will define in a second. And it is going to have the point Q on it. And now this ray is going to be made into a line, but we're going to use a dash line going downwards because this is now below the plane. So imagine this as a surface. This ST line is on the plane, and this PQ line goes intersecting through the plane. We're going to put a point V over here, and we're going to give the label N to this line that intersects that plane. So the first thing we want to do is give 2 other names for PQ and plane R. So notice that the line PQ is this line right here. It intersects through like that. And so the first thing we can do is take our line PQ, arrowheads on top on both sides, and just reverse that order and turn it into QP. Notice that this line N or line PQ also has this label N right here, so we can also call it just line N. You have to write the word line in front of it. It's not conventional to put N with an arrow. Don't do that. All right, we also want to give 2 other names for plane R. And so that is going to be the plane R right here. So this entire blue parallelogram right there. So any 3 combinations of points work. So we could take S, V, and T, for example. Or we can, instead of taking T, say we wanted to take P. So we could say plane P, S, V. We cannot use R as a point because R is not on this figure. All right, next we want to name 3 collinear and coplanar points. All right, so let's first do our collinear points. And we're just looking for 3 points that are on a line. Get rid of these blue circles there. And notice that this line right here has 3 points on them, S, P, and T. So our collinear points will be S, P, and T. And we'll put some commas there to separate those out. Our coplanar points, which we're going to do in yellow, we've technically already done one of those in naming our plane, because to name our plane with points, we have to have 3 coplanar points. They all have to lie on the same plane. So let's use S, P, and V. So P, S, and V are all coplanar. All right, we also have different types of lines that we can dive into as well. So if we make a line stop on both sides, that is going to be called a line segment. And so a line segment has 2 endpoints, A and B, or two letters, any 2 letters. So we can have that, and then if we put an endpoint here and label that A, and an endpoint here and label that B, we now have segment AB. But it has to have these endpoints. It doesn't go on forever. And we would label that by saying segment AB, but instead of putting a line on top with arrowheads, we just do a line with no arrowheads, right? And so this is segment AB. And then, of course, you can reverse the ordering and call it also segment BA. Once again, line on top with no arrowheads. Next, we are going to define what is called a ray. And a ray is a line that only has one endpoint. So if we put our endpoint there, we go out, the other side is going to extend indefinitely. All right, and so if this is our point here, C, and we put another point on this ray D, we now have ray CD. Or we can name it ray CD. Now notice how there's an endpoint right here and an arrowhead down here, so it extends infinitely in the direction of point D. So when we draw our line, we'll put a line above it, but put our arrowhead on the same side that the arrowhead is on. All right, if I draw this same exact ray, and we reverse the flow, we put the arrowhead over here, point C right here, and point D is our endpoint. Right, so in this first one, point C was our endpoint. The second one, point D is our endpoint. This is going to be ray DC and ray, oops, I made a mistake. We don't need the word ray right there. Or ray DC with the arrowhead, but now the arrowhead's above the letter C because that's where the direction of flow is going. Please know, right, note, I'll do it in a way different color here. Note that ray CD and ray DC are 2 different rays. And then finally, we can have what is called opposite rays. And opposite rays are when you have 2 rays that are connected by a single endpoint and they extend indefinitely from one another. So if we take this guy right here, draw on some blue, and we're going to call this ray EF. If we then take another ray and attach it going in the opposite direction, and I mean like opposite direction, then put a label on this. This is now ray EG. And so ray EF with an arrowhead going this way, and ray EG, arrowhead going that way. Notice arrowhead right there, are opposite rays. And notice when you make 2 opposite rays and connect them together, it looks like a line. So the key thing here is that it looks like a line. All right, so we now just have a couple of examples left to do. First, a couple of sections here in geometry are pretty straightforward and short. A lot of definitions, a lot of terms, but we're going to have two crossing lines right here. We're going to put the points E and F on this horizontal line. These two lines are going to intersect here at point J, and this other line is going to have the points H and G on it. And our first goal is to give another name for GH, and that's the segment GH. So when we say GH with no arrowheads above it, we are literally talking about from G to H. All right, so we cannot use this point J right here because if we say JG, we are going to truncate from J to H. So the only other option we have here is to say HG, just reverse the order. And then next, we want to name the opposite rays with endpoint J. So the first thing we're going to do is identify our endpoint J right here, and then now identify every ray that extends from J. So we have one right here that goes from J to F, goes indefinitely. So we'll start with JF. Make sure to put our arrowhead by F because that's the direction of travel. And the opposite ray is going to this letter E over here. So we would say that JF and JE are opposite rays. Another option is to start at J and go to G indefinitely. So we'd say JG, arrowhead above G, and then we could say J to H. And so arrowhead above H, those are also opposite rays. All right, so that's all the definitions we're going to do. I have one last example that is going to look a little bit tricky, but I promise you it's pretty straightforward. We're going to have one line right here, and it's going to have the label on it G and the label E. It's also going to have the label R, so that's line R. And we're going to intersect this line R right here with line Q, and it's going to have the labels on it D and F. And they are going to intersect here at point B. And now there's two opposite rays that extend from this point B. And so now we have A and C up here, and this line that they form is going to be called line P. And our goal is to name two planes that contain line R. So I'm going to grab my highlighter here, and we're going to identify line R, and we want to form a plane. So we need to exist all on the same plane. Let's go up to here to D, over back to line R, and then out to line Q. So these two lines that intersect right there, that is going to form one plane. So now we just need to name three letters on that plane. So we could say plane, let's do D, E, and G. All right, so let's get rid of all this yellow highlighting and identify a second plane that intersects all of those. We'll use the color blue here. We still have to go, oops, that's the pen. Use the color blue here. We still have to go through this line R, but instead of using this line Q like we did last time, let's go up to line P. And so here is going to be our rectangular shape. And now we just need to identify 3 points on there, A, E, and G. So we'll say plane AEG. So line R is in both planes DEG and plane AEG. So that is all I have for you this time. Thank you guys so much for watching. Of course, if you missed any parts, just go back and rewatch it. Pause the video where you need to, take good notes, and I'll see you in the next one.